Okay, so what are some properties of outer space? Well, one, the temperature of outer space is 4 Kelvin. So if you recall, when we talked about temperature, we said that the Kelvin scale is really the official metric unit for temperature. And at 0 Kelvin, which is called absolute zero, all molecular motion would stop. And so just as a reference, room temperature is about 300 Kelvin. So why would there be any temperature at all in outer space? Well, it comes from two places. One is the Big Bang itself. So we haven't talked about it yet, but in a later episode, we're going to talk about the origin of the universe. And so we think that the universe began as a small kernel of energy which was incredibly hot. And then as the universe expanded, it cooled off. So now it's down to about 4 Kelvin. There's also some energy in outer space from starlight, and so that would be another reason for the 4 Kelvin. Okay, then density. So the density of outer space is 10 atoms per cubic meter. So remember that a meter is about this big, so if you can imagine a box that is 1 meter by 1 meter by 1 meter, inside of that box would be 10 atoms. Now, the density of the air that's in your house, your room right now, is approximately 10 to the 25th atoms per cubic meter. So that even in your room, the density of atoms is much greater than the density in outer space. So what is outer space composed of? Well, it's going to be 99% gas, and of that 99%, roughly 90% is going to be hydrogen, and then about 9% is going to be helium, and then you're going to have about 1% dust, and that dust is primarily going to be composed of silicon and iron, but there's going to be all of the other elements in the periodic table in outer space as well. Now what's unusual about this is the sun is 71% hydrogen and 27% helium. So why does the sun have less hydrogen and more helium than outer space? Well, what has the sun been doing? So for the past 5 billion years, the sun has been converting hydrogen into helium. Okay, let's talk about what a nebula is then. So a nebula is going to be a big ball of gas that is eventually going to contract and turn into a star. So what are some properties of nebulas? Okay, so first of all, notice that the temperature is going to be 10 to 30 Kelvin. So that is going to be warmer than outer space. So outer space is going to be 4 Kelvin, and this is going to be 10 to 30. This is bad because this temperature is going to cause a thermal gas pressure, which is going to keep this cloud from collapsing and turning into a star. So let's talk about what thermal gas pressure is. So imagine that you've got this blob of gas, and inside of it are various gases, so the hydrogen and the heliums. So maybe this hydrogen is going in this direction, and this hydrogen is going in that direction, and then this hydrogen is going in that direction. You notice that I'm drawing the arrows different lengths, so that the length of the arrow represents the speed of the molecule. And so you notice that all of these different atoms in here are moving at different speeds, they're moving at different directions, they're constantly bumping into each other. And so this one might be going really fast now, but when it bumps into another atom, it might slow down, and then the other atom might speed up. So the average speed of these molecules in here is going to be controlled by temperature. So the hotter the gas, the faster the molecules are going to be moving around. And just like if you spritz some perfume that perfume scent is eventually going to get everywhere into the room, because those molecules, they don't stay put, they tend to expand. So similarly, because of thermal gas pressure, this cloud is going to want to expand. So thermal gas pressure is a bad thing as far as getting a star to be born. So we want something that can overcome that thermal gas pressure. Now, what about the density? So the density of a nebula is between 100 and 1,000 times more dense than outer space. So instead of having like 10 atoms in here, well, maybe there's like 1,000 to 10,000 atoms that are in there. So it's going to be much more dense. That's a good thing, because the more atoms you have in there, the more mass you have in there. The more mass you have, the higher the gravity is going to be, and gravity is what's going to be pulling this thing in to turn it into a star. Okay, let's take a break, and when we come back, we're going to talk about dust in outer space and what it does.